programming instructors get valuable insights from code edit history, instructors usually only see the final code students submit, but the edit history reveals how students arrived at that solution, giving valuable insights into their problem-solving process. For example, a large copy-paste segment in students' code may suggest it originates elsewhere and raises concerns about students' understanding. Timeline view has been widely applied in prior work. However, prior designs emphasize abstract activity traces and lack semantic context. Such design only shows when and where edits occurred, but not what changed. In these designs, instructors need to cross-reference timelines with code snapshots, which could add context switching overhead. Timeline view shows when edits happen, and code view shows what the code looks like. To reduce context switching, we combine them, so edits and code semantics appear in one view. While adding a few lines to the timeline is simple, the key challenges are how to scale to large code bases and how to scale to frequent real-time edits. Essentially, the system should balance detail with readability, providing enough semantic content without clutter, rapid fluctuations, or loss of legibility. We designed CodeStream, a system that visualizes code edits with code annotation on the timeline. The user interface has two views, a timeline view and a code content view. Instructors can use CodeStream to know what students try to change with the edits. The timeline view shows students' code edits in real time. The x-axis represents time from start to finish of coding. The y-axis represents code lines from the first line to the last one. Blue and orange marks show keystrokes, additions and deletions. Gray shades show students' cumulative effort. Darker ones means more effort and light ones means less effort. This allows instructors to quickly spot pauses, frequent edits, copy-paste, and unusual editing patterns. We group edits by distance on x and y axes. A pause along the x-axis often means a student stopped and started a new thought, while a jump along the y-axis suggests a shift to a different part of the code. Together, these patterns reveal different stages of problem solving. For edits in the same group, code lines are aligned by left position to keep indentation consistent. Next, we will show a recording of how it looks like in real time. The student first started by writing a welcome function. The full code is displayed on the timeline. After a pause, the student continued by writing a quicksort function. As the timeline shrinks, the two code snippets of quicksort and bubble sort are merged. User can zoom in and zoom out on the timeline to view changes of different parts. One problem we had is vertical clutter. When showing only 80 lines of raw code, readability breaks down. If we zoom out, the text becomes too small. If we zoom in, the spacing becomes overwhelming. This is vertical clutter. To handle large code bases, we use multi-level summarization. At level 1, users see line counts. At level 2, they see a flow overview. And at level 3, they can zoom in to readable details. Horizontal clutter happens even with few lines. When lines are too long, snippets overlap and become unreadable. We address this with a layout algorithm that prevents overlap and improves readability. First, we treat each edit group as a time interval and sort them by start time. This gives us a timeline of edits to work with. For each interval, compare to the later ones until their start time exceeds the current end time. Then, we check the x-axis overlap between intervals. If two overlap by more than 50%, we merge them into one. If they have less than 50% overlap on x-axis, shrink the left one and trim content with ... We did a study with 12 participants comparing CodeStream with a limited version of it without code annotations. We used real data collected from students where the code samples have 100 to 300 lines of code. Our key findings are that participants answer quiz questions more accurately than using the baseline system. CodeStream took less context switching in viewing edit history. CodeStream also helps interpret students' intent of code changes and how students invest their effort.